Hello, friends. This is DevVibe, and in this lesson we'll dive deep into important concepts such as static, factory, and Singleton in Flutter. We'll step through how they work and how to use them correctly in your projects. Let's get started. So, let's begin with the concept of static. This is one of the most basic but crucial concepts in programming. Imagine you have a class that describes something like a car. Normally, when you create objects of this class, each object has its own copies of all variables and methods. But what if you need some variable or method to be shared among all instances of the class? For example, if you want all cars you create to know about the same variable that belongs to the entire car class, not just to a specific car. This is where static comes in. In this example, we've added a variable number of cars to the car class and it is declared as static. This means that this variable belongs to the car class itself, not to individual objects. Similarly, in the constructor body, we increment this variable by 1 using increment. When you create a new car object, the number of cars increases by 1. But it increases not only for one object, this value is shared across the entire class. To access our variable, we need to do so through the class name, not through a specific instance. Now look, we created 2 cars, car 1 and car 2. When we print the value of car.number of cars, it equals 2 because this is a static variable, and its value is shared across the entire class, not specific objects. Thus, static variables and methods belong to the class, and you can access them directly through the class name, as we did with car.numberCars. This is useful when you need to store or use data that is common to all objects of the class. Now, let's move on to the next important concept, the factory method. Factory is a special type of constructor in Dart that is used to create class objects but with additional logic. This method allows us to control the object creation process and also return existing instances instead of creating new ones. A factory constructor can be named or unnamed. To create a named factory method, you need to write the name after the dot. Let's jump straight into an example and cover Singleton. Singleton is a design pattern that ensures a class has only one instance throughout the application. This is particularly useful when you need centralized control over state or access to resources. To start, let's create a class in a new file. Inside this class, we'll create a private named constructor. As we remember, privacy is indicated by an underscore before the name. Specifically, the constructor is created using the class name and a dot. Our named constructor won't take any parameters, as we don't need that right now. Next, we need to create a private static field in our class with the type of our class itself. I suggest making it final, as it will hold only one value. It might seem confusing because we have a field in our class that has the type of our class itself. But since the type of this field is static, we can do this without problems, as all instances will have shared access to this field. When initializing this field, we'll use our named constructor. Thus, we have a static variable shared across the entire application, which holds the value of an instance of this class. However, since it's private, we cannot access it directly. To do that, we'll use a factory constructor. We'll create it using the factory keyword, and since it will be unnamed, we'll just write the class name. It won't take any parameters either. Next, inside our curly braces, we'll print a message to the console indicating that the constructor has been called and return our private static variable. Now, every time the constructor is called, the code inside the curly braces will be executed. Let's check it out. We'll create 2 instances of our class. Next, we'll print the result of their equality. If true is printed, it means these 2 variables refer to the same object in memory. If false is printed, it means these variables refer to different objects in memory. Let's run our code and check. As you can see, true was printed, meaning our singleton is working. Let's try creating a field in our singleton. It will default to 0. Now, if we change the value of our variable in the first instance, it will also change in the second instance. Let's verify. As you can see, all variables are shared among all instances of our singleton, as all these instances refer to the same static object. Today, we covered 3 important concepts: static, factory method, and singleton pattern. We saw how static variables and methods provide shared data for all class objects, how the factory method adds flexibility to object creation, and how Singleton helps control the creation of a single class instance. These concepts play a crucial role in writing clean, understandable, and efficient code. If you have any questions or want more examples, leave a comment. I'm always happy to help. Subscribe to the channel, like the video, and see you in the next videos.